Hi folks, this video is on compound percentages. Now compound percentages are all about a percentage increase or decrease that is happening multiple times, and those percentage changes compound on each other. Now I'm going to take a nice simple example, and one which you may come across at some point in your lives. So the scenario here is we have a bank, and the bank is saying if you put your money into an account with us, we will pay 5% interest on the money that you have in your account per year. Okay, so we are going to start off with £1,000 and we're going to see what happens each year. And we're assuming in this case that we're not going to touch the money, that we're not going to add anything else in, we're not going to take any money out, we're just going to keep that initial investment of 1,000. And we're going to do this over 4 years. Now, one thing to note is that when we are calculating a 5% interest, so this is a 5% increase on our original amount. So as we know from our work on multipliers, a 5% increase, well, that would be our initial amount, 100%, add the 5%, would give us 105%, and therefore as a multiplier that would be divide that by 100 to get it as in decimal form, 1.05. So to find a 5% increase, we just need to multiply by 1.05. So in order to calculate what percentage, what amount we are due extra on our account, the bank just multiplies what we have in our account by 1.05, and it will tell us how much our new amount is worth after that 5% increase. Okay, so what we're going to do is we're going to go through year by year and we're going to work out how much we'll have at the end of each year, and then we'll figure out after 4 years how much is in our account. So just to remember that this 5% increase would be multiplying by 1.05 to find that 5% increase. So first of all, at the start of the year, we are starting off with the start of year 1 with our initial £1,000. And then at the end of that year, we are going to multiply our 1,000 by our 1.05, which gives us the 5% increase. So the calculation we're going to be doing here is our initial amount, 1,000, multiplied by our multiplier. And the money at the end of the year, when we do that and get our 5% increase, we end up with £1,050. Okay, and if you're following along with me, you feel free to use your calculator as you go along with this as well. So in year 2, well, we're starting off year 2 with the same amount we ended year 1 with, so we've not changed that amount, so £1,050. Now, what the bank is going to say at the end of the year, they're going to take what you've got in the account and they're going to increase it by 5%. So again, they're going to take this new amount and they're going to multiply it by 1.05. Now, one thing to note is here, this 5% increase that we're working out has now changed, because 5% of 1,000 is different than 5% of 1,050. So as we continue along our year by year account and our year by year increase, what this 5% represents is a bigger quantity each time. So it's not enough for us just to say let's find out 5% and add it on. We're going to have to do this individually, and then we'll look at a quicker method later. So in our calculators, 1,050 times 1.05 gives us £1,102 and 50 pence. Okay, so you can maybe tell straight away that the first year, let's see what happened. Well, we had a £50 increase from the original amount. But in the second year, we started with 1,050, but our increase was actually £52 and 50 pence. So this percentage increase is different for the amount that we're adding on. So we added on £52 and 50. So continuing on, we're now starting year 3 with what we ended year 2 with, 1,102 and 50 pence. And we're applying a 5% increase, so we're taking that amount and we are multiplying it by 1.05 to get that 5% increase. And if you're using your calculator, if your answer for the previous one is just on your calculator anyway, you can just do answer multiplied by 1.05. So I don't need to keep typing in new numbers. And then that gives me, I'm going to have to round this one, but that gives me 1,157 and 63 pence. Now, interestingly, this time, let's figure out how much we added on to our previous amount. So what did that 5% increase represent this time? And the way we can do that is just subtract the 1,157.63, subtract 1,102 from that. So that was an increase of £55 and 13 pence. Okay, so you can see again this 5% increase has changed the actual amount you're adding on. And then going into year 4, we're starting off year 4 with £1,157 and 63 pence. We are now applying the same 5%, we're applying a 5% increase. Obviously it won't be the same amount we're adding on. So 1,157 and 63 multiplied by 1.05 to give us that 5% increase. Again, just straighten your calculator. If you already have your answer for the previous one in, then you can just say answer multiplied by 1.05. And when you do that, you should end up with 1,215 and 51 pence. Again, just rounded that 2 decimal places because we're dealing in money. And then a nice thing or an interesting fact might be, just let's work out how much that increase was actually worth in pounds. What was that new 5% increase worth? So I'll just take my 1,157 and 63 away from 1,215.51. And that was an increase of £57 and 88 pence. Now, a few things to note when we go through this. First of all, at the end of year 4, we end up with £1,215 and 51 pence. So overall, the increase over those 4 years was £215 and 51 pence. But note the actual increase per year changed every year. And the reason for that is our original amount that we're taking, that 5% and increasing it on, is different each time. Therefore, what the 5% represents will be different each time. And the last wee thing to note is that the 5% actually increased, but it increases quite fast. So the difference between £50 and £52 is smaller than the difference between 52 and 55, and so on. So if we kept our money in there for longer and longer, so more and more years, then what would happen is our 5% increase would compound on itself and make a much larger increase as the years go on. Now, what we'll do is we'll go on ahead and look at some examples now. So these are examples that you would be kind of expected to come across. Now, one thing to note is that this is a long-winded method here, and there is a much more efficient method of going through this, of these compounded percentages. Now, just note that what I've done each time is I've taken my original amount, I've multiplied it by 1.05, and then I've taken that answer and I've multiplied that by 1.05. Then I've taken that answer and multiplied that by 1.05, and so on. And I've multiplied by 1.05 4 times because there was 4 different increases that I was looking at. Okay, so the increase in year 1, increase in year 2, increase in year 3, and increase in year 4. So a shorthand way we could work this out is we could take our original amount, £1,000, And all we did was we multiplied by 1.05. Then we took that and multiplied that by 1.05. Then we took the answer to all of that and multiplied it by 1.05. And then we took the answer to all of that and multiplied by 1.05. I'll put that down there. Okay, so let's see if we can simplify this. What we ended up with was this big long calculation. And if we know our power as well, we know we can simplify this to our original amount. So what we started with at the very start, £1,000, multiplied by this 5% increase 4 times. So we can write that in power form, to the power 4. And that is our shorthand method of doing this long table method. So doing it year by year was the slow method. We can make the calculation a lot more efficient by taking the power of this percentage. Note that I increased by 5% 4 times, so therefore my power was 4. And my initial amount is what I started with at the very start. So this is the shorthand compound percentage formula for that question. Now what we'll do is from now on we're just going to be looking at the shorthand method, but we'll look at some examples now. These are the types of examples that you would be expected to come across in your exam years. Example 1. Kirsty runs a distance of 18 miles per week. She decides to increase her distance by 10% a week for the next 4 weeks. How many miles will she run in week 4? Okay, first of all is to recognise this as a compound percentage question. So we have a percentage increase, so increase her distance by 10%. But crucially, this is happening multiple times. So this is happening each week for 4 weeks. So this is a compound percentage question. Now the way we go about a compound percentage question is let's work out what multiplier would represent this percentage increase. This stage you don't need to do, so I'll write this in green, but you don't need to copy this in if you're confident that you can tell what multiplier we would use. But we start with 100%, and an increase of 10% means that our new percentage would be 110%, and therefore as a multiplier, divide that by 100 would give us 1.1. Okay, so the multiplier we are going to be using for a 10% increase is 1.1. Now, in week 4, Kirsty will have ran. So we take her initial distance, which is 18. She increased that 4 times by 10% to get to that 4th week. So we multiply that by our multiplier, but we need to do that 4 times. So we're multiplying by 1.1 4 times, which gives us 4 lots of 10% increases. And then as simple as just putting that in your calculator. So 18 times 1.1 to the power 4, which gives us 26.3538. Although it's not told me about any rounding specifications, I'm going to write my unrounded answer first. It's not too long a decimal. And then if you want to round that after, then you can. So let's just say she runs 26 miles. Okay. Right, so example 2. In the evening, the temperature in a greenhouse drops by 10.2% per hour. At 6 PM, the temperature was 27 degrees Celsius. Find the temperature at 11 PM. Now again, first of all, you need to be able to spot that this is a compound percentage question. So we have a percentage decrease this time, so drops by 10.2% per hour. Now, this is happening every hour, and we have multiple hours between 6 and the time that we want. Okay, so we are looking at a 5-hour difference between 6 and 10, so it's decreasing by 10.2% 5 times. So this is definitely a compound percentage question. So the first thing to do is let's work out what multiplier we would use for a 10.2% decrease. So again, to find out our multiplier, we work out what happens to our original amount in terms of percentages. So 100% dropping by 10.2%, which gives us 89.8%. Oops. Okay, and then as a multiplier, we divide that by 100 to get it in its decimal equivalent, which is 0.898. Now, after every hour, we are going to be left with 89.8% of what we started with at the start of the hour. Now, we are going to be doing this 5 different times, so for every hour between 6 and 11, so for 5 hours. So to set up at 11 PM, the temperature would be what we started with, which was 27 degrees, multiplied by our multiplier, 0.898, but we're applying this percentage decrease 5 times, so to the power 5. And then again, just straight into your calculator, 27 multiplied by 0.898 to the power 5, and I end up with 15.7668, blah blah blah. Okay, so a bit more of a longer decimal this time. I'll write my unrounded answer first, and then it's again not specified any rounding here, so I will just round it to 1 decimal place this time. And that was degrees Celsius. Example 3. Example 3. A savings account offers 0.5% interest per month. How much would an investment of £250 be worth in 3 months' time? So very similar to the question at the very start of the video. Again, first of all, recognising this as a compound percentage. So we have a percentage increase, which is happening over a certain time frame, and this is happening 3 times. Okay, so we're working out this percentage increase 3 times. First thing to do is work out what multiplier I'm dealing with. So starting with 100%, an interest would be an increase, so increasing by 0.5%. And just take your time to make sure you get the correct multiplier here. So we actually end up with 100.5%, which as a decimal comes out as 1.005. Okay, so that's the multiplier I'm going to be using. Next thing is to set up my actual percentage question now, my compound percentages. So in 3 months' time, we have our initial amount, which was 250, multiplied by our multiplier, so our 0.5% increase, but we're increasing by 0.5% 3 times because it's over 3 months. So we end up with, again, straight into your calculator at this point, 250 multiplied 1.005 to the power 3. And double check, you should end up with £253 and 77. So this time I'm rounding to 2 decimal places because I'm dealing in money. So 77. Okay, so this is what I would end up with after 3 months. What I want to know is how much interest would be earned. So the interest is just that extra money that the bank has paid into the account. So in this case, let's see, I started off with £250 and I ended with £253 and 77 pence. So just a simple case of saying that interest earned is equal to my 253, so my final amount, subtract my 250. And I'm writing this as a column here, but you would have a calculator in this case. So 773 0, 0. So £3.77. Okay, and you can maybe have just worked that out straight from looking at the two numbers. Okay, so that was compound percentages. What to do next is go and do a good bit of practice on this using the practice sheets. And then we'll look at being able to spot compound or being able to spot reverse next time.